Okay, hey guys, so today we're going to go over day 4 notes. That's going to be converting volumes to moles and vice versa, so moles to volume. So in chemistry, we use the initials STP to represent the standard temperature and standard pressure. So standard temperature is equivalent to 0 degrees Celsius, and standard pressure is equal to 1 atmospheres. Okay, so the molar volume of any gas at STP is 22.4 liters. So in other words, 1 mole of any gas at STP is equal to 22.4 liters. Okay, so that's going to be our conversion factors when going from volume to moles or moles to volume. Okay, so in our little conversion factor table, 1 mole, again, is equal to 22.4 liters of any gas. So this only applies to gas. Okay, so let's go ahead and work a few sample problems out. Okay, so number 1. The average lung capacity of a male is 6.0 liters, and the average, not lunch, but lung capacity of a female is 4.7 liters. So assume the following. If your teacher's lungs are completely filled with oxygen, determine the number of moles of oxygen gas in the lungs of your chemistry teacher at standard temperature and pressure. So our given is going to be 4.7 liters because obviously I am not a male teacher. So our given is 4.7 liters of oxygen gas. Okay, because remember, it's going to be filled with oxygen. So our chemical symbol for oxygen is going to be O2. Because remember, oxygen is a diatomic, so we never want to see it by itself. Okay, so we're going to multiply that with our conversion factor. Since we are going from liters of oxygen, and our question is asking us to determine the number of moles, then remember what we're trying to find always goes on top of our fraction. So since I'm looking for moles, my 1 mole of O2 is going to go on top, and then our conversion factor when going from liters to moles, well, our conversion factor is right here. So 1 mole equals 22.4 liters. So 22.4 liters is going to go at the bottom. Okay, so remember, these are going to be diagonal of each other. They always, you always want them to be the same unit. So if this is liters, then the unit that you want on the bottom of your fraction also needs to be liters. Okay, because remember, we're going to cancel out our units, so whatever we're left with, that unit that we're left with, moles of O2, is going to be for our answer. Okay, so what is 4.7 divided by 22.4? Okay, so if you didn't know why we divide, remember that whatever number you have on top is always going to be multiplied, and then whatever number you have on the bottom is always going to be divided. So it's going to be 4.7 divided by 22.4. So let me get my calculator really quick. Okay, and let's see. Okay, so I have my calculator. Let's go ahead and work this problem out together. Okay, so 4.7 divided by 22.4, and we get 0.209821. Okay, but of course you don't have to write all that down. So 0.209 And we'll just stick with that. Okay, now remember, this is not our final answer because we always want significant figures. So if our given is 2 significant figures, then my answer must also be 2 significant figures. So remember that when counting significant figures, your leading 0 is never included as a significant figure. So the 2 would be our first significant figure, and then that 0 is our second. So what does that 9 do to that 0? It's going to round it up. So our final answer would then be 0.21 moles of O2. Okay? All right. So, moving on to question number 2. Okay, so number 2. At standard temperature and pressure, how many moles are found in 54 liters of neon gas? So our given is going to be 54 liters. So 54 liters of neon gas. So neon on your periodic table is represented by the letter Ne, right? So again, we're going to multiply that by our conversion factor, and since we're going from liters to moles, again, our conversion factor is going to be 1 mole equals 22.4 liters. Okay, so remember, what we're looking for should go on top. So since we're looking for moles, moles is going to go on top. So 1 mole of neon, and then remember, diagonal rule, so liters of neon, the bottom should be liters of neon too. So our conversion factor is 22.4 liters of neon. Okay, so again, when we solve this on our calculator, it's going to be 54 divided by 22.4. Okay, so 54 divided by 22.4, and our answer is 2.4107. Okay, so again, significant figures. Okay, we were given 2 significant figures, so my answer should also have 2 significant figures. That's the first. This is the second, so my final answer is 2.4. And then again, what's going to be our units for our answer? Well, remember, liters of neon cancels out liters of neon, and we're left with moles of neon. So moles of neon, which is exactly what we're trying to find. Moles of neon. Okay, so that's our second answer. Okay, and then let me box this one in too. Okay, and then our last problem for today's notes. Question number 3. How many liters are found in 3.02 moles of helium at standard temperature and pressure? So again, our given is going to be 3.02 moles of helium. So 3.02 moles of helium. Okay, and then we're going to multiply that with our conversion factor. So remember, if we're going from moles to liters, then our conversion factor is going to be 1 mole equals 22.4 liters. Okay, so remember, what we're looking for is going to go on top. So in this case, we're looking for liters. So this time, 22.4 liters is going to be, oh, we are looking for helium, not neon. Okay, so 22.4 liters is going to be on top, and then our 1 mole is going to be on bottom, which is correct because remember, when we cancel out units, moles is going to cancel out with moles of helium. Okay, so when we solve, it's going to be 3.02 times 22.4, because remember, whatever number we have on top, we're going to multiply. Okay, so let's take a look at our calculator. Okay, so let me go ahead and delete all this. Okay, so 3.02 times 22.4, and our answer is 67.648. And then, of course, we want to check significant figures for our answer. We have 1, 2, 3 significant figures in our problem. So 1, 2, 3. What does that 4 do to that 6? It stays the same. So 67.6, and then of course the only unit we have left is liters of helium. So liters of helium. And that is our final answer. Okay, so if you had any questions, please feel free to ask, and that concludes our notes for today.